Hello, and welcome to today's SEI webcast. Secure systems don't happen by accident. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make today's webcast as interactive as possible, so we will address questions throughout today's presentation and again at the end. And you can submit those questions in the YouTube chat area now, and we'll get to as many as we can. Now I'd like to introduce our speaker for today. Tim Chick is the Technical Manager of the CERT Applied Systems Group here at the Carnegie Mellon University Software Engineering Institute. Tim currently leads a team of software and systems engineers as they build and operate technical solutions for both internally funded research and customer-facing prototypes, and deliver trusted, valued, and relevant software engineering and cybersecurity approaches for software-intensive systems through engineering and consulting in support of the United States Department of Defense and Department of Homeland Security programs. Let me welcome in Tim at this time. Good afternoon, Tim. I'd like to turn it over to you. Good, all yours.
All right, thank you very much. Appreciate it. So here, I'm going to take really a perspective of why a program exists. From an engineering perspective, software development, how do I secure and build a system? Because it doesn't happen by accident. We have to design it, we have to build it, we have to integrate it. We can't just bolt on that security construct in the end. But it really comes down to three dynamics when looking at a program or an enterprise that they really care about. Well, one is, why do they exist, right? What's that value proposition? Who are their customers? Who are their stakeholders? And the other two really is the product itself, that thing that they're delivering, they're selling, that service that they're providing, as well as their ability to deliver value, right? And all of that needs to be secure. All that needs to be considered when trying to build really an ecosystem of value for your customers and for your users, stakeholders. And so that really gives you two challenges. One is that the dynamics of it, right? These things are constantly changing, right? It's not a static solution. I can't build it, design, or engineer it one time and we're done. But software really doesn't work that way. It's really iterative, especially when you get into Agile and DevSecOps, things of that nature. The processes, the tools I use, the technologies, they're constantly changing and evolving. Even my customers' needs are changing and evolving. And so I have to change with it. And that change is a challenge, right? The second one, the one we're really going to focus on, is the fact that, sorry, where's that? That's what I talked about the process for. The second one is the cybersecurity piece, right? Traditionally, what happens is that, you build your product and you focus on building this moat around your product, right? Defend the network, things of that nature. Problem with Agile and DevSecOps, what has happened is that the compression of the throughput and the time between engineering and deployment and the connection, you've built this huge bridge over your moat between your development environment and your product. And so now what has happened is from a cybersecurity perspective, your attack vector is the entire ecosystem, right? From a cybersecurity, I can attack your DevSecOps or development environment and actually impact your operational environment, right? And so we've exponentially increased the attack surface of our system. So we've increased that challenge as well. So, and the problem we have is that from an attacker's perspective, they only need one opening in our armor, right, to get through our defenses, right? So we have to defend it completely, or hope they don't find it, or one little weakness. Some little data there, right? The application layer is the new perimeter. So most cyber attacks now, instead of just getting through basic network security type of issues, they're actually getting into our systems through our APIs, through features that they're able to manipulate in order to exploit, and do something with our system that it wasn't intended to do, right? 9 out of 10 breaches are due to defects. So our design code really does matter. And the 56% of developers struggle to prioritize valuable vulnerability fixes. We'll talk about kind of why that is, why that struggle comes from in the dynamics of between value, scope, resources, and being able to focus on cybersecurity practices. Some kind of disheartening facts, the way the world is coming, right? 90% of organizations knowingly release vulnerable applications. So we know it's vulnerable, we release it anyways, right? 57% of vulnerabilities are left unresolved by developers, right? This one I kind of, the 32% of folks deploy vulnerable code in the hopes that they won't be discovered, right? So like, I know it's there, it's vulnerable, but I just hope nobody finds it, right? It's not really a good risk strategy there, right? And then 60% of data breaches are caused by failures to apply available patches. So how quickly can we update our software and apply known solutions to vulnerabilities really has an impact as well. Some of the cost implications to our businesses, right? On average, a data breach costs over almost $2.5 million. It's even worse for healthcare and financial systems. I don't want to read all of these, they're there. But one I found kind of neat, right, the very bottom, 42% of companies have actually paid for the returning of stolen data, of which only 8% of the businesses that do pay actually get their data back, right? So you have almost half the companies are paying, for ransomware, but then only 8% are actually getting a return on that money, actually getting their data back, right? And so cybersecurity is a problem for us, right? It's hurting us, the companies, the government, it's a major problem, right? And so the way we need to address that is through our engineering development, right? As you know earlier, 50% is really coding and design flaws, right? So how do we do that, right? And there's really three constructs that I want to focus on today. One is third-party software. We don't actually build a lot of applications from scratch. We actually glue a bunch of applications together and add new value or new capabilities to a system. And then we'll focus on quality. Quality really does matter. And so why does that matter, and how does that impact cybersecurity? And then the third one is what can I do? How can I actually engineer in, what techniques can I incorporate into my engineering lifecycle to actually help mitigate the risk and improve the cybersecurity hygiene of my products and my systems. So the first one, third-party software, right? So today, like I said, most programs are actually, it's too large for a single organization to build all that code, right? They either procure through vendors or open source software, a lot of the lower level specialized applications, and then they take those pieces, they might have some specialized software of their own that actually makes the value proposition for that system, for that business. But there's also lots of little components that really don't have enough individual value in themselves that's worth a company paying their developers, their engineers to actually write that piece of code. It's more economical to use open source or a vendor who's selling a certain solution that can find multiple users instead of the scaling from an engineering perspective, right? So open source is also rising, right? 90% of modern applications use third-party components. At least 75% of organizations rely on open source software to do a lot of their fundamental aspects of their code, right? So we're really just gorging ourselves on expanding and using open source components. And so what's the ramifications of that, right? And so people are taking notice that we're becoming more and more dependent on third-party software and open source software. The top is a reference to a government memorandum. Is basically saying that when you're using open source or third-party software, you need to make sure that they are following secure development practices, right? Why does that matter? Log4j is a great example of an open source software that almost everyone uses. Amazon, Apple, Cisco, a lot of major large applications that almost everyone has on their networks, on their computers. They were vulnerable because of an open source piece of software, right? In 2023, approximately 60% of applications had third-party flaws. 70% or injected their own flaws, and 70% had flaws from third party. So third party actually makes us more vulnerable than the code we're developing ourselves. Not much, 63 versus 70, but it just goes to show that we really do need to start taking notice as to what open source software we're choosing to use in our systems. And how can I do that, right? There's 4 major types of evidence that we should be looking at to evaluate when considering third-party software to establish confidence that the supply chains we are using are acceptable, right? We started asking ourselves, has the supplier shown that they have the capability to manage their supply chain? This is because the software from our vendor is also using third-party software, right? Does the supplier product exhibit that it has built using acceptable supply chain risk management, right? Do they deliver do the delivery mechanisms used by a supplier safeguard the product security? And when implementing the product is used and updated in a secure manner, meaning it's fit for purpose criteria, meaning am I using that third-party software in the way in which it was intended to be used, or am I doing something with it that really wasn't intended to use? So I should begin questioning, does it actually mitigate the new vulnerabilities or the new threats to my system that third party might not be designed to handle or address? We also start thinking about, and there's some other government guidance out there that says, hey, if you're going to use open source software, you need to actually start thinking about, addressing long-term support, right? Using trusted sources, understanding the dependencies, right? And kind of the table up in the far left is kind of the things you can start looking at from those perspectives, right? For example, dependencies, right? Do they have a published software bill of materials, right? How many dependencies are there between the different open source software applications, right? You start looking at trusted sources, right? Are they publishing the actual source code? Or are they just publishing binaries? Am I using the source code and compiling it myself, right? Which also can help for maintainability. I actually have a copy of the source code. I can also begin looking at some basic hygiene of an open source repository. This data is publicly available, right? How many people are maintaining that system? Does it only have one maintainer, right? So are other people looking at the software? Are other people evaluating it, right? How often is it being committed, right? Are they doing peer reviews, right? Is there any evidence of doing that, right? Last one, right? The person who actually is building this, that one person who's committing it, is it a known malicious actor, right? Are they using a pseudonym that we've seen in other places, right? So these are some things you start looking at when we start evaluating your open source and third party, right? You shouldn't just blindly download a piece of open source software. Another thing you could do for open source or even vendor based, what version of it am I using, right? If you Google it, you might get the most popular version. That might not be the most secure version, right? That particular version might have a known CVE against it. So you really should be using a newer version or a different version where that vulnerability isn't available, right? So you should think in those terms as well when doing open source selection or third-party selection. So the next category I want to switch to is quality. And why does it matter, right? So what is software quality, right? It really refers to how well the software product conforms to its requirements and meets the needs of its users. There's 2 primary aspects of software quality. One being the perspective of the product itself or its characteristics in terms of reliability, usability, performance, and security. The other one goes into the process piece. It goes after what are the tools and the techniques used to actually build the product, right? Are they using best practices? Are they improving the quality of my software, right? And so from a traditional perspective, when a project looks at a project or a project manager looks at a project, what they look at and what they believe that they can negotiate is really scope, schedule, and cost, right? The piece that one really should never negotiate is the quality of the product. Why is that, right? Well, so if my quality isn't there, then my scope isn't exactly what I need. It's defective, right? If my quality isn't there, right, my schedule is not going to work. I'll be late. I can't get through testing. I can't deliver what I promised, right? So my schedule starts slipping, right? And then if scope's not what I want and the schedule, then the cost will also increase as well, right? And so I get late deliveries, cost overruns, and reduce scope, right? But from an agile perspective, when you start thinking about, the agile way of looking at it, they think of all of these things as a constraint, right? It's fixed variables, right? And so they look on terms and they think quality and value are negotiable, right? So here's kind of the negotiation from an agile DevSecOps perspective. The problem with this is that most organizations usually want to deliver features and products to customers quickly at minimal cost, right? And so they really focus on the value and the constraints when doing their balancing. Quality always seems to suffer because it's hard to measure the constraints and values, right? I can't quantify quality as easily as I can value and constraints. But the problem is quality costs us a lot, right? In terms of productivity, lost GDP, right? It costs the United States $2.4 trillion a year, right? In terms of lost productivity, in terms of waste, right? That includes security failures, operational failures, finding and fixing defects, right? Technical debt, right? This really all adds up to a lot of inefficiencies. So there is a cost to it when you look at it from a macro scale, but you also think about it from a micro scale, and we'll get to that in a second. So why am I focused on quality, right? So defects result in weaknesses or potential exposure to systems and failures that a cyber attacker can exploit, right? Because really weaknesses come from flaws in my design, bugs in my code, or vulnerabilities using bad open source or third-party vendors who have known, vulnerabilities or CVEs associated with it, right? And all of this comes from are found during the coding, the architecture, implementation, design, the requirements phases, right? Because these are the phases where the phases that we're using to build the system, right? This is where the weaknesses are injected into the product that we're selling or service that we're providing. And when I use the word weakness, right, I also interchange it sometimes with vulnerabilities, right? But they are two different things, right? A weakness is just a mistake or a flaw in my system that may or may not be a vulnerability because you might not actually be able to exploit it, right? The exploit is actually the action taken to take advantage of that vulnerability to do something with my system that a bad actor would want to do with it, right? And I'm focused on defects and quality, again, because studies have shown that 1% to 5% of defects are vulnerabilities. And to kind of put that into numbers and perspective, right? If I take the Boeing Dreamliner, which has had some quality issues over the years, right? If I said, well, you know what, it's still exceptional code, even though they have some vulnerabilities. Well, it's 14 million lines of code, right? And studies have shown, the best in class, there's basically about 600 defects per million lines of code. So we're talking, the Dreamliner has at least 8,400 defects. If 1% to 5% of defects are vulnerabilities, right, it has basically, at least 420 vulnerabilities. If it's an average software development, and maybe some other quality issues, maybe it is average, right? We're talking about 4,200 vulnerabilities, right? And you kind of get the idea. You can do the same thing with like the F-22 or the F-35, right? Defects are proportional to the number of vulnerabilities. So the lower the quality of the system, the more vulnerabilities in my system, right? And so when I think about quality, again, you think about when are defects injected and when are defects removed, right? So defects in general are injected into my system during my creation phases, right? I'm being creative as an engineer during the requirements, during design, during the coding aspects, right? But then what I need to figure out is how do I get rid of those defects earlier in my system where it's most cost effective, and what engineering techniques can I use to reduce the number of defects that escape my system, that actually become operational, right? And kind of another view of that concept is here, whereas, traditionally, right, most defects are actually injected during the requirements and design architectural aspects, 70% of them. 20% is coding, and then you get a little bit less, 10%, right? These are when defects are injected. But the removal really ends up being at the end, right? Is that 50% during that unit testing integration. Problem with that is I can't actually test quality in my system. Testing proves the lack of quality, but it doesn't prove the existence of quality, right? So just like quality, cybersecurity is a life cycle challenge. I need to bring this all together. I need to look at, from a quality perspective, I look at through this entire life cycle. I need to do the same thing for cybersecurity. How do I take the time to look at what engineering techniques can actually improve security early on in my system, can minimize and reduce my vulnerabilities, can reduce my attack surface, or look at my features and make sure my features can't be misused by an attacker or some adversary. Just a note here, a lot of things I'm talking about, I'm focusing on the product itself. The same can be applied to the CI/CD pipeline, right? I do care about that life cycle, right? What tools did I pick in my development environment? Are they secure? How are they being integrated? So everything that I'm talking about while I'm focusing on the product is equally true to the CI/CD pipeline. You know, SolarWinds is a great example of that, right? Another famous attack, right? They basically, if you read into it, what the attacker did is they found that sweet spot between the completion of all my testing and right before deployment or operationalization of the product by sending their system to their customers, right? And that is where they injected their vulnerability, right? That, you know, because all the testing is done, it passes my static, my dynamic, my integration testing. They're doing everything great, I'm assuming, in terms of good engineering practices. But that one spot between the transition between I've done all my testing, my product's good to go, and actually shipping out the door, that was the spot at SolarWinds that they got them, right? The other thing is what tools did I pick, right? Git, a very popular configuration management tool. That one had a vulnerability in it, which really allowed people to take advantage of as well. So you got also, you know, third-party evaluations, you should be using the exact same concept when you think about your automated testing tools, when you think about your repository that you use, right? So your pipeline, the same concepts apply when building that as well. And this idea of attacking, you know, the capability through your services or your value chain isn't new, right? This is kind of a decade old. But you know, a steel plant was attacked in 2014. They basically got in through business services that happened to be connected through to their actual physical plant. They actually caused damage to the plant, right? So you again, you know, this cyber physical connection is very much live and well, and the attacks are getting better and more sophisticated as they move forward. So when I talk about quality from a software engineering perspective, in terms of security, it's really talking about software assurance. That's really the discipline that really gets good cybersecurity hygiene early into the software engineering lifecycle. And software assurance is really all about ensuring that the system only functions as intended and it's free of vulnerabilities and weaknesses that can be exploited by adversaries, right? Again, you can't test in software assurance, right? You need to have good engineering. You have to have peer reviews and other concepts that focus on cybersecurity. And ultimately, you know, even when you do these things, while you're reducing the risk of an attack or an exploit being taken advantage of, it's really just risk mitigation, right? I can't, you know, no matter how good my software is, there are going to be some defects. Studies have shown we just don't know how to build perfect software. So there will be some vulnerabilities. So the key here is think about how can I minimize the risk, right? In terms of my system being exploited, my system being taken advantage of, how can I mitigate some of those risks as well, right? And think about mitigations. And one way of thinking through that from an engineering perspective is actually build an assurance case, right? Using assurance cases, you know, in software isn't a totally new concept. We use it for software safety analysis all the time. The key there with software safety is they have the benefit of the laws of physics, right? If this happens, this plane will crash. If this happens, this thing will explode, or someone would die. They'll be over radiated, right? But you can still do the exact same type of analysis from a cybersecurity perspective. You can think about, this system is secure. Well, how do I know that? What techniques, what practices did I develop? And then people can start poking holes at my claim with defeaters, and then I can begin looking at the evidence and changing my practices and my techniques to reassure and build a holistic assurance case that my product, as well as my pipeline, I do the same thing for that, is really only being used as intended, right? And even if the adversary gets in, there's mitigations to reduce the impact or the damages caused. By design, I've built this into my system. So what are those engineering security practices? What are those engineering things that I can do to build a more secure system, right? It doesn't happen by accident. So it gets to this concept of secure by design, right? There's different memos, the government's talking about it. A good definition of secure by design that I like came out of Jen Easterly, right? Was the third one down, right? The expectation that technology is purposely designed, built, tested, and maintained to significantly reduce the number of exploitable flaws before it is introduced to the market for broad use, right? It doesn't say it's eliminating it, right? It's significantly reducing the number. Again, it's risk mitigation. How do I build a better product by design to minimize the probability of being exploited? And so when you look at that, you have to look at the entire software development lifecycle, right? As well as your pipeline, as well as your supply chain, because all of these things impact my ability to build a secure product. So how do I look at that? What are some of the things from a system engineering perspective, right? I can begin identifying threats to my environment and to my operations. How would someone want to take advantage of my product? What are the threats there? I can generate actual specific requirements. What are the non-functional software assurance requirements for my system? How do I know it's a good system that's free from vulnerabilities and weaknesses, right? So I begin doing some system engineering analysis, and I begin testing and validating those assertions throughout my development lifecycle. Right, when you do that, you really think about design weaknesses, code weaknesses, and implementation weaknesses. Right, so first one, security requirements challenges, right? Often security requirements are developed independently of the rest of the requirements engineering activities, and hence are not integrated into the mainstream of the requirements activities. Problem with that is that when a developer builds a system, they focus on the main requirements. And if your security requirements aren't integrated with them, they will not have an equal footing, right? I've seen it lots of places where organizations will say, from a security perspective, your system will be compliant with some security standards, such as, the NIST, risk management framework, security controls. Well, the problem with that is it's a byproduct, right? It's not really impacting my design decisions, my architectural decisions, right? It's not specific to my system. It's very generic, right? So it really results in security requirements I really need that are specific to the system and that provide the protection of essential services and assets that are often neglected, right? What are the things that are unique to my system that have to be secure, that have to be protected, right? So it should be part of that requirements solicitation process, right? And they really need to focus on not just what the system should do, but what the system should not do, right? We don't normally write those negative requirements of our system, but that is really what's important when you think about from a cybersecurity perspective is what do I want to make sure my adversary is not able to do with my system, right? What are the abuse cases that someone could try to use my system for, right? How do I think of those? Those should also be written as requirements, right? So to do that right, I really need to anticipate ways in which the system can be misused. I need to perform really rigorous your threat analysis of my system. So that's one of the techniques I should be doing, is doing threat modeling, right? I should associate attack methods with the likely identified threats. So you look at like MITRE's KPEC, for example, there's lots of different attack methods that one can use. I can align there's attack methods with my threats, and then I can develop mitigations to reduce the possibility of that happening to my system, right? So early specification of security requirements usually has a positive impact on fundamental architectural design decisions to enable security concerns to be addressed from the ground up, right? Instead of bolting it on at the end. And so it kind of gets into this threat modeling, right? So what is threat modeling? Really, it's really the process of creating an abstraction of your system and then aiming to identify what the attacker's abilities and goals would be for my system, right? If an attacker could get into my system, what would they want to do? Why would they want to do that? And so it really creates that mindset of defensive thinking. What I want to be able to do is every time someone, developer or a user or someone says, hey, I really want your system to be able to do X. They give me a new requirement or a new feature request that they want. I take a step back and go, okay, how could that feature be misused? What are the threats to my implementation of that feature? Because I could implement that feature in several different ways. Which one would minimize my attack surface? Which one will, protect me the most from my adversaries, right? And so there are different threat modeling techniques you can use. Here's a few of them. And kind of how does that work to my Agile? Well, we do Scrum. I don't have time to do this big upfront heavy system engineering construct, right? Well, so I can do threat modeling on a per feature request aspect, assuming I have some existing system and some architectural views of my system. So then I do a risk analysis, right? And so that risk analysis should be part of my prioritized backlog, right? My prioritized backlog should represent the variety of stakeholders' views and priorities. It's not just the end user that sets priorities of my backlog, right? I have to think about security. I have to think about the other relevant stakeholders and balance that. And when I build my prioritized backlog, some people focus too much on one view of value, being the end user. While that's an important aspect, it's really not sufficient because most end users don't think about security. They assume that you're selling them or you're providing them a secure product, right? So it really needs to be part of maybe your definition of done. But some features are design features. Some cybersecurity features have to be designed and built. So they will be in your product backlog, where other aspects of security could be as part of your peer reviews or your evaluations or your definition of done. And that kind of gets into like code hygiene, your DevSecOps process, right? Some of those things you can automate with tooling, and then you release, right? And then in terms of your Scrum roles, right? Think about that persona non grata, right? How could someone misuse my system, right? You can easily do that. Another approach to cybersecurity is really embracing model-based systems engineering, right? So take a system view of your application and model it, right? You can build instead of doing just living off your product backlog or maybe some requirement specifications, right? Actually build a model of your system using SysML and model-based system engineering techniques, because that will open you up to being able to start evaluating your system holistically from a threat perspective, right? So what I can able to do is I can identify the threats, I can integrate that with my architecture, I can model the architecture, I can find security design flaws in my architectural designs, but then I can mitigate them, right? And what you can do is some people do tabletop exercises. You do some type of workshop or scenario where you bring the right stakeholders together and you walk through the different architectural views of your system and you start building threat scenarios, right? And what do I mean by a threat scenario, right? So I really want to think about, for a given activity or a given piece of my architecture, what type of actor, is it insider threat? Is it external threat? Is it a developer? Developers make, their quality, their defect might be a threat to my system in a scenario. What actions do they take? what information is disclosed, what's the attack, what's the asset of focus, and what's the effect, right? And why would they want to do it? What's their objective? What's driving their behavior, right? Is it just laziness from a developer's perspective? Is it, they actually want to cause harm economically, physically, right, to my system? With those elements, I can combine them, I can build a statement, right? For example, as an insider threat publicly releases the results of my static and dynamic analysis to the public to damage the organization's reputation, right? So that's a threat to my pipeline, right? And then when I do these workshops, when I do these exercises, I need to think about who participates. What are the different views of the system? What are the backgrounds of those folks? Or help me identify these threats and build these threat scenarios, right? The system users, how would they use it? Could they envision misusing the system? Some cyber experts who actually understand attack vectors, who understand the different techniques that cyber attackers use and exploiting and taking advantage of various systems. And then you want the developers and the systems engineers, because they're the ones who most intimately know what the system can and can't do, right? Because they're the ones that built it. Once I do that, I bring that together and I build these threat scenarios, what I'm able to do is, for example, if I say it's like DevSecOps pipeline, for example, writing code, right? That's an activity that developers do, right? So I can actually write threat scenarios around how someone could take advantage of the code writing activity in my pipeline, right? The critical role being the developer, right? But then I say, okay, well, who are the attackers, right? For these threats, what KPEC technique could one execute to make this threat happen, right? And then from here, the next step would be, how would I mitigate these threats? How would I protect myself from the risk of this threat actually becoming a reality to me, right? So then I begin designing and building in to my system, architecturally and designing to mitigate and address these issues upfront and early before I deploy, before I make this system available to my customers and my user base. Right? Using DevSecOps, right? Empirical evidence has suggested that organizations incorporating automated quality analysis and DevSecOps practices will observe improved quality through the improved discovery of deficiencies in their system, right? And so what type of automation can I do from a cybersecurity perspective, right? And what are some of the motivations of using that automation, right? Well, it reduces, I can do from manual code reviews, I can automate those, right? And so there's different sets of tools, it's kind of a hierarchy. So they're actually a pretty good blog that kind of outlines the differences. But what I can begin doing is I say, okay, from, I can run static code analysis tools, right? Static code analysis tools are very good at finding common weaknesses in terms of coding practices and standards, right? It can help you find, code that might result in a buffer overflow, for example, right? I can also use a dynamic analysis tools, right? These tools are really good at looking at, using fuzz testing and looking at, have an API, for example. What happens when I give it data it's not expecting or data that's not within its normal parameters? Does it fail gracefully or not, right? So dynamic tools can help you with that perspective, right? Origin analysis, decomposition analysis tools, right? These can help me begin identifying what version of what open source tools and libraries is this product using, right? Do they have known vulnerabilities in it? Should I be using a different version or a different product, right? And then databases, am I ensuring that, no one is storing any passwords in my database, right? Or my secrets in my database, right? Basic hygiene from that perspective as well can be looked at. And then it progresses up in terms of more complicated tools that use the bottomless tools as their foundation, but does initial analysis, does additional evaluations, right? So you can progressively move up and improve through automation from a testing and a quality perspective. right? So how do I pick my tools? What do I think about? I think about basically, how much time does it take? So just because it's open source doesn't mean it's free. For example, there's lots of automated testing tools out there that you can just download for free and use them. But now you have to configure them, you have to maintain them. The documentation with some of them are not as well. They're not, there's not a help desk that you can call and ask for support. Um, you also think about, so that impacts your time, right? I can always just buy a good tool that comes with support. Well, that costs money, so there's my budget, right? But then I also think about, does this tool match my product, right? I don't necessarily want to buy an automated testing tool that's geared towards a Windows-based system when I am building a Linux-based system, right? I need tools that really work in the Linux ecosystem if I'm building a Linux-based system. Or if I'm building an app, right? Certain testing tools are much open or much more applicable to, mobile device testing than it is for my system. And there's also like static code analysis, right? They're good at different types of programming languages, right? So you begin thinking of that. What are my objectives? What are my risks? What type of things am I concerned about? And is that tool good at finding them? Because what I understand is if the tool is not good at finding them, then these are the things that I should be focusing on in my manual process, like my peer reviews, right? You begin thinking in terms of that nature as well. Right? Just taking to take a holistic view of not only can I use automation to improve my cybersecurity hygiene and my product, but I can also do threat analysis requirements. I can design a better system because some tests are good at finding coding flaws, but it's really hard for automated testing to find design and requirements flaws, right? Those much more human intensive activities. So with that, I do want to open up to questions and some interaction. The idea here is if secure by design is accomplished through integrating the cybersecurity engineering tools and practices throughout the lifecycle of the system. Ideally, with software assurance, I'm able to really build a trustworthy, predictable, and a timely system that really meets the intent of that secure by design, right? That I'm able to sufficiently reduce the number of exploitable flaws before it's introduced to the market for broad use. So with that, Shane, do we have any questions?
Yeah, Tim, before we get to that, I just want to give our audience a shout out. We had really a worldwide audience that I saw. Brazil listed in the chat, Mexico, Las Vegas, Tennessee, Canada, Japan. So it's just always so great to see seeing that many countries represented and people joining our webcast. We truly appreciate everybody's time and taking the afternoon to learn with us. So the only current question in the queue, Tim, is about will the slides be available from the talk? And I said we can make a PDF available post event. I can send out a link for that, but one of the questions I had, Tim, is I know you have a workshop coming up here in August, Secure by Design. It's the second annual one. Can you give us just a quick highlight of what you're looking for there? I know the call for papers is still open. What are you going to look? What are people going to learn at this workshop? And I know it's free.
Right. So we kind of looked at, there's lots of cybersecurity conferences out there, but what we felt was most of them are really focused on the operator's view, right? How do you defend your network? How do you, insider threats? How do you look at, hackathons? How do you actually attack a system? But what we didn't see is one focus on the software engineers, the developers, the people who actually build these systems. How do we build them more securely? So what we did was we tried to create an event where people could come in and talk about the engineering aspects. How do I build a better system? How do I assure my system is secure and it can only be used as intended, right? So that's really the goal of the event, is to really bring engineers together to talk about cybersecurity. Because there's lots of other events and conferences out there where cybersecurity analysts can get together and talk about cybersecurity. We want to bring that engineering construct to the discussion, right? Which is a little bit different than, I quoted CISA, Jen Easterly, right? With their definition of secure by design. I like their definition. I'm using it here, but their focus is actually focused on getting companies to make a pledge to do better, provide better, more secure systems and software to the customer, right? Because traditionally, what many companies do is they build their products, they give it to their users or their customers, but they make them agree to a licensing agreement that basically says use at your own risk, right? Any damages caused by my product that you're using is your problem. Is basically what most user agreements say. What they're trying to get at is okay, we need to do better, right? We need to take ownership of security because the attackers are getting much more sophisticated. And so we can't trust, or we can't assume that the average user of your system is capable of securing their system, right? Or locking it down, right? And so what they're trying to get as organizations, companies, to take ownership of that up front and say, okay, I'm going to give my users a more secure system by default, right? And what we want to do to kind of marry with that is we want to help engineers understand how to actually achieve those pledges that many companies are making.
Great. And comment, secure by design, that is a in-person event, right? But from my
Yes.
understanding, some things will be captured, though, Tim. There'll be recordings available.
Yeah, so we didn't want the logistics or the of that hybrid environment. So the event will be in person, but we will be recording the presentations and post the event. We will post, I imagine, on the SCI's YouTube or somewhere. We will post the videos of many of those presentations. So we do want to make it available to the wider community. But we also want people to attend so we get that engagement and we get the conversation going.
Great. We had a comment from Philip of going to submit a paper on embedding zero trust networking. So good to see you from Philip. A great question from Roy, Tim, for you. And I'll read it here. I understand all that you said, but do you really expect the developers to do all that you said? How realistic is that? So is this a change in mindset that people need? Or is this, you're going to have a breach at some point, you're going to pay for on the back end, and are you suggesting, it comes down to time and money? So how do you respond to that?
Right. So part of why in the presentation I included a bunch of facts, right? I quoted a lot of statistics and data and studies is because really, engineers need to help make that business case to their stakeholders, right? And go, okay, but I can't sacrifice quality. Here's why, right? I can't sacrifice cybersecurity. I have to do good engineering, right? And so that data matters. Most executives are risk. They're smart people because even managers, different levels, right? But you have to have that conversation, and most people don't have that conversation, right? And so I'm hoping that by providing that data, providing that talk track, say, okay, here's the methodology, here's the method you should be using. If people are saying we don't have time for that, well, then you should be able to say, well, here's the consequences of not doing that, right? Companies lose money because of these flaws, for these vulnerabilities, these cybersecurity attacks. And if I don't build it in, right, it's not going to be there, right? And you're starting to see from a business perspective, executives are starting to get it, right? A lot of companies are signing on to, the CISA's secure by design pledge construct. And so it's that middle management tier that needs to be brought on board with doing this. And you're right, developers and engineers, they're overwhelmed. We ask them to do so many things. And so that's where DevSecOps comes in, right? Let's automate the routine. Let's automate the turn the crank activities so they can focus on the stuff that really requires the human intellect, right? And that's really where these engineering techniques require that, right? I don't need if I'm doing a code review, for example, right? I don't want a developer to spend their time focusing on syntax issues, right? You have a coding standard, right? A static code analysis tool can do that. right? What I want a developer to be focusing on is, is this code meeting the design of my system? Is it violating my architectural constraints to my system, right? Because if I've done my threat analysis and I've built mitigations to my system, now I'm looking at from a coding perspective, am I conforming to those design and those architectural decisions, right? Because I've designed in the security aspects, right? That's a good use of a developer's time from a code review perspective. The same thing is true for the design implementations, right? Most developers want good requirements, right? They don't want to spend most of their time doing technical debt and bug fixing at the back end, right? Or not being able to get through some testing or acceptance criteria. But at the same time, we don't necessarily give them the acceptance criteria early on during the requirements phase, right? It's that black box, right? You see it all the time in the government with the authority to operate construct, right? So basically, in the government, they have to, at least the United States federal government, all of them have to go through the risk management framework and this standard, which has a whole bunch of cybersecurity controls in it. Well, sometimes those things are not actually looked at by the developers up front because it's not part of the requirement set. No one's asking them about that. No one's focusing on that until the very end when they're ready to deploy it. When they're done, they've actually spent all their time and money and resources on engineering, designing, and building the system to all of a sudden find out there's all these other, I guess, requirements or constraints that no one told them about, right? So developers want good requirements. They want good architecture. They want good design. They want to build a good product. They need to understand quality includes security, but it also requires systems engineering and other disciplines to engage with the developers. And actually engage with them, not just be a wall of no, right? It can't be an adversarial engagement. It has to be a collaborative, right? Which is kind of the definition of DevSecOps, right? It's bringing developers, security, and operational people who actually have very conflicting interests, right? A developer wants to create new capability or new features, right? A security person is focused on defensibility. They don't care about new features. They will care about, is it defensible, right? And an operations person is focused on stability, right? They don't care about security. They don't care about new features. They care about my uptime. Is it always available? Because that's what they're being graded against, right? And so their interests aren't always aligned, right? But from a business perspective, they need to work together throughout the entire development system, right? From requirements through operations. They need to be in lockstep and they need to be able to balance their different interests and build a good, secure application. That's kind of a long-winded answer to the question. I hope I hit it.
Next, we have Tim. Do you have anything to add to the tension between agile and quality? Even the lack of requirements makes it challenging to test and therefore promote quality, right?
Yeah. So what I find a lot of agile groups that I work with, right? Quality is an attribute. So it's usually not in your user stories. It's usually not in your product backlog. But it should be in your definition of done, right? And it should be one definition of done. It's a different definition of done for each different type of activity, right? What's the definition of done for coding? Well, all code should go through a static code analysis tool. All code should be configured into some type of configuration management tool. All code should be peer reviewed, or at least reviewed by one additional developer or peer, even if you don't do like a formal like Fagan inspection concept, right? All software needs to pass automated testing. Well, what does it mean to pass automated testing, right? Well, I should have fuzz testing. I should have these different types of testing, integration testing, right? And so that's usually where I find people fall short in terms of quality. It's not built into the definition of done. It's not built into the engineering practices and expectations of the project and the program, right? And some of that comes from contractual requirements, so the business case. Some of that needs to come from the user community in demanding higher quality systems and products. But the way you address it is in the definition of done. It's not in the product backlog itself.
Great. We'll let you get out of there on this one, Tim. From Ryan asking, what are you looking for in presenters for Secure by Design? So I know the call's been open for a little bit, nearing the close here. So there are certain topics you still would like to address, or types of speakers, so we can wrap on that one.
Yeah, so for me, anything in the software development lifecycle, right? If I go back to, you know, these bigger, higher level views of the slides. If I go back to this one, anywhere in the software development lifecycle, right? How do I address design weaknesses? How do I design? What are some design techniques one could use, right? Requirements, right? What are some good techniques? Threat modeling. Does someone have a good technique that they've used or tried, or a variation of some published technique that they think is an improvement? Coding, right? Static code analysis. There's all kinds of tools out there. Is there a new technique? Is there a new way? How is this being used? What I'm not interested in is sales pitches, right? Don't come trying to sell your tool. Let's talk about the technique. Now, if your tool or whatever it is can provide an example of how that engineering technique can be applied, that's probably okay, right? But let's focus on the engineering aspects, and then maybe have examples of tools and things that help make that useful, that makes that usable by the community. But I want people to walk away with the techniques, because they might want to use a different tool. They might want to use a different way, but they learned about this new approach that they can begin to try to incorporate when they get back to their companies and their organizations, to actually improve the security of their systems, right? So that's kind of what I'm looking for is the engineering. How do I engineer a better product, a more secure system, so it's secure by design? Those are the types of talks we're looking for.
Great discussion today, Tim. Thanks for sharing your expertise.
Great, my pleasure.
And we all would like to thank you all for attending today. Upon exiting, please hit the like button below and share the archive if you found value. Also, you can subscribe to the SEI YouTube channel by clicking on the SEI seal in the lower corner of the video window. Our next webcast will be June 27th, and the topic will be generative AI and software engineering education. Registration information is on our website and will be emailed out as well. As always, any question from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.